Factorization means writing the numbers in product form, like 16 is 2 8s, or we can say 16 is 1 16s, or we can say 16 is 4 4s. So 4 4s or 1 16s or 2 8s, or even writing in the way like 2 into 2 into 2 2s is 4 and 4. So 2 2s is 4 and 4 4s is 16. All these are different ways of writing a number in factorized form. So that is called factorized form. But writing 16 as 15 plus 1, this is not a factorized form. So factorized form always consists of multiplication and not addition or subtraction. But then we have another concept called prime factorization. Prime factorization. So prime factorization means writing the number in a factorized form, but only by using prime numbers. So though 2 is a prime number, 8 is not a prime number. This is not the prime factorization. Or we can say this is incomplete prime factorization. 1 into 16, 1 is not, of course, a prime number or composite number. So this is also not a prime factorization. 4 is a composite number, so this is also not prime factorization. And since 4 is a composite number, this is also not termed as a prime factorization. But if you really want to write 16 as a prime factorization, it should be 2 into 2 into 2 into 2. So 2 2s are 4, 4 2s are 8, 8 2s are 16. This is a prime factorized form. So we are only using prime numbers and we are not using composite numbers. So remember, all the numbers like 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and there are infinite number of prime numbers, of course, but using only prime numbers to write them in a multiplication form, in a product form, is called prime factorization. So let us now understand how are we going to write a number in terms of its prime factors. Let's take a simple example. Let's take 20. So we can write 20 as 120s. Nice. But 1 is neither prime nor composite. It's a unique number and 20 is a composite number. So let us split this 20 into a further factorized form. Okay. So we can write 20 as 2 10s are 20. Now we know 2 is a prime number, but 10 is not a prime number. So we can further split 10 as 2 5s are 10. And now 2 and 5 both are prime numbers. We can bring this 2 down as it is. Just put a multiplication sign, otherwise it will look like 22. So 2 multiplied by 2 multiplied by 5 is 20. 2 2s are 4, 4 5s are 20. So this is called the prime factorization of 20. Another way to factorize 20 is this way. We are only going to write prime numbers over here, no composite numbers allowed. So we'll start with the smallest prime number, which is 2. And we shall divide 20 by 2. So we know 2 1s are 2 and 2 zeros are 0. So we have 10. Now 10 is a composite number, so it goes in some or the other table. So it's 2 5s are 10. And 5 is a prime number, so we're going to write 5 as it is. And 5 1s is 5, and we can put a dot or nothing over there. And therefore we can write it as 2 multiplied by 2 multiplied by 5. Let's take another example. The second example, let's take 48. Now we know 48 is 1/48, but then we can split 48 as 2 24s. And then we know 2 is a prime number, so we are going to just bring it down as it is. But then we are going to split this 24. We know 24 goes in the table of 2 again. So it's 2 12s. And then we know 2 is a prime number, but 12 is not a prime number. So we are going to further split this as 2 6s. and then we are going to split 6 as 2 threes are. So we are going to do this till we get all prime numbers, and we are going to bring the 2 down as it is. So we have this 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 3s is 48. But what if somebody over here attempted in a different way? For example, he or she may have attempted this as 8 6 are 48. Of course, 8 6 is 48. But then we need to split 8 as maybe 2 4s are, and then further split 4 as 2 2s are, and split 6 as 2 3s are, and then bring down the 3, bring down the 2, bring down the 2, and finally we'll have the same answer. 2 into 2 into 2 into 2 into 3. So whatever your branches are, you'll get the same answer, even if you attempted in this way to find the prime numbers. So 2 2s are 4, 2 4s are 8, 2 1s are 2, 2 2s are 4, 2 6 are 12, and 2 3s are 6, and 3 is a prime number, so 3 1s is 3. You'll be getting the same answer. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 3s are 48. Let's take another example. This time let us take let's take 51. Now it's very difficult to know 51, is it a prime number or a composite number? If it's prime number, it's a prime number, but we know 51 is not a prime number. 51 is a composite number. So 51 goes in the table of either 2 or 3 or 5 or 7. So let's divide it by 3 first. So 3 1s is 3. So if you're not sure, you should go with this method. 3 7s is 21. Yeah. So it goes in the table of 3 and 17. And since 3 and 17 both are prime numbers, we are done. This is the final answer. And of course, while doing it in a vertical method, we are going to start with 3. Of course, this does not go in the table of 2. It's an odd number. It's not an even number. So 3 1s are 3, and 2 is the remainder that carries, and 21, 3 7s are 21, and 17 is a prime number. So it is very important for us to know at least till 100 which are prime numbers. Now 17 is a prime number, we knew that. 3 is a prime number. So it is very important for us to know whether it's a prime number or a composite number, and accordingly we'll come to know where should we stop it. Okay, so practice more sums with this, and see you in the next video.